Hi, this is McMay's Research Consult, and today we want to talk about the indirect utility function. Specifically, we want to know how to derive the indirect utility function out of the direct utility function that we already know or we've already introduced ourselves to. And so we want you to just get ready for us as we move on. Now, what we know is that in the direct utility function, the consumer always had to maximize his satisfaction based on the quantities of the commodities that is being consumed. And so you can see that the utility maximization was a function of the quantities of commodities that are being consumed. So the quantity X and bundle Y, they give an amount of satisfaction. So the consumer always is thinking, how much can I get to maximize my amount of satisfaction? But in the indirect utility function, we are saying that the consumer is rather going to maximize his satisfaction, but that will be based on the prices and the wealth of the prices of the commodities, as well as the wealth of the consumer. So the sharp contrast is that for the direct utility, the consumer is always trying to maximize his satisfaction based on the quantities of X and Y. But with the indirect utility, the consumer is going to maximize his satisfaction based on the prices and that of the wealth. So that's how we are able to say that the indirect utility is dependent on the prices and wealth. So this tutorial is to help us transform a direct utility function to an indirect utility function, which is dependent on the prices and the wealth of the consumer. So in that sense, then we have to understand that suppose our utility function is of the form UXY, which is subject to the wealth combination of expenditure on the X commodity, expenditure on the Y commodity should be equal to the consumer's budget. So from equation 1, we can see from equation 1 that the consumer really has to earn a marginal utility, which is equal to X. Now, the marginal utility of Y should also be equal to, the marginal utility of X should be equal to Y from equation 2. And that is because if you take a look at the utility function, direct utility function, if you differentiate U with respect to X, that gives you Y because of product rule. If you differentiate utility with respect to X, then you're going to get Y. But if you differentiate utility function with respect to Y, then you're going to get X in the equation 1. So we say that the marginal utility of commodity Y is equal to X, and that the marginal utility of commodity X is equal to commodity Y. Now we know the maximum utility function condition, which suggests that for any two commodities, the marginal utility of commodity X with respect to the price of X should be equal to the marginal utility of Y over the price of Y. And this is stated in other way as in the equation 4. Another way we could state it as the marginal utilities of commodity X and Y should be equal to the marginal utilities of commodity, should be equal to the price ratios. So equation 4 is saying that the marginal rate of substitution, the MRCS, should be equal to the price ratios. In that way, we are going to have a tangency between the indifference curve and that of the budget line. And the slopes of the indifference curve will be equal to the slope of the budget line. At that point, we shall achieve utility maximization. So when we substitute equation 1 into equation 2, that means where we have the marginal utility, we're going to replace it by X, marginal utility of X, we replace it by Y into equation 4, then we get equation 5 as this, suggesting that marginal utility of X, which is equal to Y, over the marginal utility of Y is equal to X, should all be equal to the price ratios in equation 4. So substituting the equation 1 and 2 into equation 4, the maximization condition That gives us the equation 5. And so we are going to continue with our substitutions and say, so from equation 5, what happens is that we are going to solve for x in equation 5 and solve for y in equation 5 also. Solving for y in equation 5, which is this equation 5, if you try to make y the subject, that gives you equation 6, because you're going to cross multiply and then you're going to get px times x all over py. That is equation 6. You want to find x also. It means that you need to cross multiply both sides, then you divide through by px, and that gives you equation 7. So you can see from here, this is not a final conclusion. This is not a conclusion, but you can see from here that even finding y from the profit utility maximization condition suggests that y, quantity y, depends on the price of y, which shows that it is negatively related to its own price, but it's positively related to the price of commodity X. So equations above suggest that y is non-increasing in its own price, suggesting that an increase in the price of y will reduce the quantities of y that will be bought. Similarly, look at equation 7. It suggests that x is non-increasing in its own prices. Exactly. But it's non-decreasing in the prices of other goods, y. And that is the typical relationship of demand that will be introduced to you in the longer term as you advance. So from equation 6 and 7, we see x depends on both prices and the quantities of y. Similarly, y depends on both prices, but also the quantities of x. Now, from equation 5, we are moving on to form the very x that we found in equation 5, the x and y's. We are going to substitute each of them into the budget function, if you could remember. So these are, so coming from deriving the equation 5, where we had the x and then the y's, from the utility maximization condition, we are going to substitute each of the x and that of the y into the budget function. And so let's do that for y. From equation 6, we know that y was equal to pxx over py. When we substitute that into the budget function, then it leaves us with pxx plus price of y times the y, which is equal to the total budget. Now let's solve for x, because we are going to have these canceling out that. And so we're going to have all in terms of pxs and that of x. Then we're going to make 2px equals to x. Then finding this x, make this x the subject, that leaves us with the x star equals to m over 2px. That's equation 8. This is the demand for commodity x. So here we are saying that demand is negatively related to its own price. That's how we derive the demand function. But it's positively related to the income or the wealth of the consumer, which suggests that demand decreases with increase in price, but demand increases with an increase in the wealth of the consumer. Similarly, so substitute equation 7 into the budget line. Equation 7 was for x. And so we're going to have px, and the x equation from previous slides was pyy over px. And that means these two would also cancel out, leaving us with pyy plus pyy. Same way we solve for y. And that gives us the demand function for commodity y in equation 9. So the demand function of commodity y suggests that y is also negatively related to its own price, but positively related to its wealth. Again, it means that the demand functions for the commodities x and y, they are negatively related to their own price, but positively related to their income. And that is why when you write the demand function, is A minus BP, such that A is positively related and that of P is negatively related to the quantity demanded. Now, since these have become our demand function, now let us go and substitute these X star and Y star into the direct utility function. Doing that means that we are going to transform from a direct utility function to an indirect utility function. And let's see what happens then. In that substitution, then we are saying that for all good X and Y, which is X star, Y star, putting that into the utility function suggests that this U star will now be a function of X star, which is M squared over 2px. And that of Y would also be the M over 2py. Okay, so let me cancel out these two here. They shouldn't be here by now. Yes. So the value for X was found as M over 2px, and that of the Y star was also M over 2py. Since we can do some multiplication out there, then suggests that the utility function, total utility function now, is expressed as M squared over 4px and py. By this, we can say that the consumer can maximize his total utility, which will now be dependent on the price of X as well as the price of Y. These two are having negative effects on the total utility the consumer can achieve. However, total utility can now be positively motivated. Suggests that the more wealthier a consumer becomes, the more he's able to buy goods and services, then the more satisfaction he can derive. However, the more the prices of goods and services, the lesser the wealth, then the lesser the utility that could be achieved indirectly. So we are saying that a utility function is now written as a function of price and wealth of the consumer, but not in terms of quantities as shown in the direct utility function. Should you have any other feedback, you may put into the comment section. I will look it up and then advise on the next tutorial. In our previous tutorial, we introduced you to the Wawersen demand function, which was the normal demand function, and how to derive the direct utility function also. You might want to revise and take a look from there. Once you are okay, see you soon and take care.